Assalamualaikum and good afternoon. Welcome back to my channel. Okay, welcome back to my class. Okay, as we promised, so today we are going to proceed to the next chapter. Actually, we go back to the previous chapter, which is chapter 4. The Greek connected PV system is chapter 5. Now we go back to the chapter 4, which is standalone system. I think maybe some of you are waiting for this chapter, but don't expect too much. As a disclaimer, basically the items taught in this chapter is not coming from the SEDA. Okay, it's coming from several books that we referred, me and Dr. Shawal during develop these contents. So this is the one of the simplest way to design the standalone PV system. Okay. Again, I repeat, this is not the SEDA certified module like the GCPV, the grid connected one. The grid connected, we are following the SEDA guidelines, but this one is coming from the several books that we refer, and this may be one of the simplest way to design the standalone PV system. Okay, if you plan to install by yourself the standalone PV system, I think there's no problem with that. But if you plan to be as the consultant, to consult the some other person for commercialization, I'm not recommend lah. This is the risk lah, because we're not coming from it's not coming from the SEDA lah. Okay, if you plan to do seriously, I think you go to company, then you design simple so okay, it's okay, no problem. But if you go seriously with the bigger scale and so on, that's better you refer to the SEDA or the certified one lah, or you can refer other materials also. Okay, so this is the disclaimer. Okay, I will record again and you will see back. So don't blame me if something happen when you are doing the design. So this is disclaimer lah. So after completing this module, you are expected be able to design simple. The term simple PV standalone system. Simple. Okay, the simple. Okay, not the a proper SEDA certified standalone PV system module. Okay. Alright. Before that, can you hear my voice clearly, or does my video pausing or lagging? Is it okay?
Okay, Doctor.
Okay. Alright. So let's proceed. Okay, let's proceed. Okay. Standalone, or we've called that as the off-grid also. Standalone system does not have a connection to the electricity main grid. That's why they are called also as the OGPV. What is the OGPV? Is the off-grid. Okay, off-grid. So not only the standalone PV system, but we call it also as the off-grid PV system. Okay, so standalone system vary in size from washers or calculators to remote building or spacecraft, mega scales, gigawatt scales now recently. So if the load is to be supplied independently of installation, the generated power needs to be buffered with a battery. I think most of you are aware with this. If we to be supplied independently of installation, mean during the solar irradiance season or solar irradiance hour, which means during the day lah. Okay, during the day installation. If it is installed for the sake to be used independently of installation, which is for example during the night, then all the generated power that we get during the day must be buffered or must be stored in a storage battery. That's why the battery is quite common in a standalone PV system application. For me, it's very odd for those standalone PV system that are not that are not equipped with the battery. It's very odd and weird. Okay, because basically standalone PV system, you must have the storage battery. If not, there's nothing we can do during the night. You're going to be living in the darkest night. Okay. Okay, this very simple, super simple structure. We have the PV array here. So the symbol of PV array, and we have the DC load here. We have the AC load is under the loads. And other than that is the balance of system, including the battery bank and also charge controller and inverter and so on. But it's okay lah. if we divide into three main components, PV array, because it's the PV system, we must have PV array. If we are installing the wind system, wind energy, then here comes the wind turbine. Okay, wind turbine, wind turbine. So this part not PV array anymore, it's going to be wind turbine. And we go wind turbine, usually charge controller. For the PV based charge controller or for the PV use charge controller, sometimes they call it as a is it uh charge controller with the inverter maybe Sunny Boy. They call it Sunny Boy. I think yeah. Charge controller suit with the inverter one set. We call it a Sunny Boy. If for the wind turbine, wind energy system is called as the Windy Boy. Don't ask me why they're called boy lah. They just name it as like that, so I just follow up. Okay. Then we have the charge controller. We have learned before what is the purpose of charge controller. The most important thing charge controller is used when you have the battery connection in order to prevent the over discharging of the battery and also the overcharging of the battery. That's why we need the charge controller. Okay. Like we learned also before, the MPPT charge controller is the most suggested one. I think please forget the PWM and series controller shunt and so on. Just focus on the MPPT charge controller. Remember me, MPPT, maximum power point tracking based charge controller, is the most suitable to be used in the standalone PV system. Okay, so that is always driving your power to the maximum. Okay. And remember, this is the charge controller and this inverter. Okay, the standalone inverter, usually it will be based on the 12 volt, 24 volt, or 48 volt. Okay, 12 volt, 24 volt, or 48 volt. My suggestion is at least to have the minimum 12 and 24 volt. Usually, they maybe have the 12 volt base inverter, 24 volt inverter, 48. Usually, 12 and 24 are multi-channel lah, which that inverter also can support both 12 volt and 24 volt of system voltages. Okay, but for 48 volt usually separate lah, and the price also is slightly expensive than the 12 and 24. Okay, again, if you plan to buy the inverter but don't buy yet, don't put in the cart in the Shopee yet. Find for the keyword of pure sine wave inverter. Okay, pure sine wave inverter. Usually they said solar car inverter. Please don't buy that. Even though they have the until 1.5 kilowatt with less than 100, don't trust them. Because what is the issue? The issue is the efficiency. You know, our ideal efficiency may be more than 85%. If you go for the grid connected inverter, they can go up to 98.7%. But for the standalone PV inverter, I think 85% should be the minimum one. If you try to buy in the internet, in the online shopping, if you can't see the, what we call it, trusted efficiency with no data sheet that you cannot Google, please avoid that. Just try to avoid that because usually the price is very cheap. Very cheap. Please cross check with the any data sheet that available. If you plan to buy the inverter in the online shopping, please check, please find or ask the shopper for the data sheet, original data sheet, to make sure that you are not cheated by the description. Okay. And then distribution panel, because after the standalone inverter, so this is about AC lah. Okay, the AC part. Okay, and then we have the DC load, and DC load if we use the 12 volt base load. Okay, for example LED. Okay, LED 12 volt base. Okay, that's for DC load. Usually they have, now also they have the table fan, but and then maybe air conditioner also. Maybe you can see. Or the AC load depends on the size of your load. Okay. Boleh dengar saya kan? Boleh kan? Kau saya cakap seorang. Boleh ke?
Boleh. Boleh.
Alhamdulillah. Okay, alhamdulillah. Okay.
Nak tanya sikit boleh?
Amdir?
Nak tanya sikit.
Silakan.
Nak tanya. Cuba slide belakang tadi tu.
Oh, slide belakang. Okay.
Lepas dari MPPT dia keluar DC kan?
Lepas MPPT apa benda ni? MPPT charge controller ke? Ni ke?
Dia akan keluar DC.
Yang ni? DC. Semua DC.
Lepas tu nak pergi ke AC load, dia masuk inverter kan?
Betul lah. Dia charge controller ni tujuan dia untuk prevent tu je battery over discharge and discharge and charge je, overcharge. And then input untuk inverter kan DC. Yang ni AC. Lepas AC ni lah.
Kalau farm dia tak ada battery kan, dia terus ke pesawat.
Solar farm.
Solar farm.
Solar farm tak ada charge controller, tak ada battery. Dia ada grid inverter saja. Dia terus sambung inverter. PV array tu maksudnya kalau untuk grid connected tu solar farm kan. Ni tak ada. Terus ke grid inverter lah. Terus ke grid. Belakang ni grid lah.
Jadi dia tak ada MPPT pun kalau solar farm?
Ada. MPPT ni pada inverter. MPPT inputs ni pada inverter.
Bukan pada charge controller?
Bukan pada charge. Dia tak ada charge controller. Kalau untuk yang solar farm tu memang pakai grid inverter. Grid inverter memang input channel dia tu memang dah MPPT function dah. Macam lah charge controller tapi bukan charge controller pun. Dia konsep dia tu dia dah suit sekali dengan inverter tu lah. Tapi MPPT function tetap ada untuk inverter pun.
Alright.
Grid inverter. Boleh?
Boleh.
Uish, tanya soalan dah. Baru awal lagi. Belum lagi, jauh lagi perjalanan kita. Okay. Boleh Right. Okay. Limitation of sizing the standalone PV system. Okay, the weather records for the site may not be detailed enough to do an accurate calculation of the module output. Okay, the weather records for the site may not be detailed enough to do an accurate calculation of the module output is not the same as the temperature weather forecast that you see in the news. Okay, weather forecast or you see in the internet. That one may be temperature, humidity, rainfall. That one precipitation, wind speed. That one may be already established. And the value of the temperature, humidity, and so on now very established. Then you can see even the forecaster here and there. You can see the forecasted value everywhere. But for the case of weather record for the site may not be detailed, ini referring to the solar irradiance to be specific. The solar irradiance we don't until this level, until this moment we haven't seen yet the weather forecaster in the news or in the internet showing that the total solar irradiance for the Kuala Lumpur from 9 a.m. to 10 a.m. is about now. We haven't get that kind of value yet. Why? So this is the since the weather record are a summary of the past, because the forecasting the solar irradiance is not the same to forecast the ambient temperature or the humidity. That one very straightforward and you can compare directly with the measurement and so on. Yeah, of course we have solar irradiance meter, but for the solar irradiance it's quite critical. Okay, once the cloud is changing, if the cloud is just pass through at the moment, also change already the solar irradiance. That's why for the sake of solar irradiance forecasting studies, they are now still in the level of research. Masters and PhD studies. A lot of papers and journals are doing the forecasting study of the solar irradiance. Okay, what we get for the case to predict, we only have the past record or the historical record. Okay, weather records are a summary of the past. They can only suggest what may happen in the future when the solar system is operating. Same thing. We can. That's why the forecasting study is there to predict how much is the energy that will be generated tomorrow. Okay, based on the historical data. Okay, that's why it's difficult to predict accurately how much ST will be generated. This is will be generated. Difficult study. I mean, forecasting study, prediction study of the solar irradiance is quite critical. They are doing the forecasting until the level of in the ionosphere, something like that lah. Scattering apa semua lah. Dah sampai level tu lah. Tahap tu. This is quite critical lah. So that's the problem of the one of the standalone PV system. Same with the JCPV. But JCPV, we are focusing on selling, okay, selling the electricity to the electricity provider or the client or the customer, which is customer is the TNB, Tenaga Nasional Berhad. But for the case of standalone, usually people are doing it for ourselves. I mean, we install the standalone PV system to facilitate our necessities, our energy demands in our place. That's why it's very critical to know the weather record or to know the historical data for the last year or for the previous year, so that when we install the PV system in our place, it works. Right? If our place that always raining in months, every month we have maybe raining season, for example, so that one is not suitable lah. That's why very critical to see the weather records. Fortunately, there are the weather records in most, not most, in I think the popular places or the capital city of the state. Capital city apa? Silap. Ibu negeri apa? Ibu negeri. Uh, we have met meteorological apa aku tengok met apa? Meteorological department. Okay, meteorological department can provide us the solar reading data also, if I'm not mistaken. Then what we need to pay lah. So they have that data in popular stations. For example, in the nearest to our place in Kuantan and the Muazzam, for example lah. Okay, the nearest station that we have for the solar irradiance. Not only the humidity and temperature, also we have the data of solar irradiance, as the additional information lah. Okay. Right. Okay. Step to design a standalone PV. Sekejap PV standalone, sekejap standalone PV and whatever. Okay. Off-grid, OGPV, whatever lah. It's all about off-grid PV lah. So okay lah, OGPV also we can say it. If the SEDA punya course, nama OGPV, OGPV, off-grid photovoltaic. Okay. I think this the step of the exam for us is very super critical to know. I think several parts in ourselves or in most person doesn't have this kind of thinking. Okay. The first step is very critical for me. What is that? Calculation of the load energy demand. Okay. The keywords here is the energy demand and determine the appropriate system voltage. Energy demand. What is the load energy demand? Is all about the load that we want to use in our PV system on that particular schedule. Okay. If we plan to use 20 bulbs of the LED and 1 unit of portable DC aircon, for example. So our design of the PV, our size of the watts must be based on that energy demand. Okay, you can't change. You can change, but if you change, then you need to recalculate to add. Maybe there's necessity to add one more PV module, for example, or you need to scale up your storage capacity. Once you decide to use this kind of device or units of the appliances, then it's there. After that, we calculate, we choose the suitable PV module size, and we choose also the battery. What is the appropriate storage battery for that system? Okay. The mistake that happened, I think, in many newbies of the PV installers or PV lovers, likers, apa? They have budget, of course. They have budget, they have money, but maybe at certain point they don't think or they don't plan it because they maybe haven't read the proper books or something like that. So they always forget what they say. I want to use the air conditioner for 24 hours, but my budget is only 200 Ah of the storage capacity. That's nonsense, okay? Because it's not enough. Once you use the air conditioner, especially to be honest, all people want to use air conditioner unlimitedly with the what we call that, PV standalone system base. Okay, everyone wants that, seriously. But believe me, believe me, 1 horsepower of the air conditioning tower has 747 watt. Okay, in 1 hour it will consume 747 hours. 747 watt hours of the energy in every hour. So imagine if you want to use 10 hours, then you are going to need almost 7.47 kilowatt hours of the energy. 7.47 kilowatt hours per energy. You need a very high capacity. Okay, for example, if you have the 100 Ah of the battery, I just saying at a glance, kita pergi secara rough dulu, secara nak bagi fikir. 100 Ah, then your battery is 12 volt, right? Even though the I written 100 Ah, you can't actually use the exact 100 Ah because we are bound with the we call that as the depth of discharge. In most cases, deep cycle lead acid will only 50%. Means that if you have 100 Ah, actually you can use only 50 Ah, not the 100 Ah. You're not going to get 100 Ah, definitely. You may get more than 50 Ah, but 50 or 55, maybe you can get, but you cannot get even more than 60 Ah also. Even though the battery is declared as the 100 Ah. That's a different story. We call that as the DOD, depth of discharge. Okay? That's critical. I think this kind of depth discharge, people or newbies, they just have the battery, they calculate just like that, and then suddenly install, and then, oh, not enough energy. The battery dies. The battery dies. Why? Maybe battery is not good. No, it's not the battery is not good. It's actually the calculation that we are not really good with that. That's the problem lah. So first of all, remember, load energy demand. How much watt hours or kilowatt hours that you want to use for your system. Okay, this watt hours including all per day. I'm talking about the load energy demand per daily, every day. How much energy you need to use. For example, if the aircon you want to use 1 horsepower for 10 hours, means that you're going to get rough 7.47 kilowatt hours of energy. That's the words there. Then based on that, you're going to choose the appropriate system voltage, whether 12, 24 or 48. Okay? Boleh aku cakap seorang ke ni? Sekejap. Tanya orang ni. Jamadil. Faham tak Jamadil? Jamadil. Tak ada. Khairul Ikhwan.
Yes, sir.
Boleh pair tak? Boleh faham tak?
Boleh.
Boleh
Boleh.
Mirul.
Kira tu.
Boleh ke?
Boleh.
Boleh lagi belum masuk question lagi, kita baru introduksi. Okay. Alright. And then after we know the energy demand, we limit our nafsu to that energy demand only. Then we choose the appropriate system voltage by considering that we are not going to upgrade at that moment. Okay. If we want to upgrade, then we need to revisit balik recalculate all the calculation. Maybe you need to add up one more modules or batteries. Okay, like that. Okay. Then survey of solar resource and the selection of PV modules. So let's survey of solar resource too. That is the data for the peak sun hours. Okay, the data for the peak sun hours for that particular area. It can be generated. Met also, the Meteorology Malaysia also can provide that kind of data, but you need to pay. And then also you can generate the interpolated values of the solar irradiation or the peak sun hours on that particular location lah, using the PVCVs or Meteonom. Okay, software, for example. Then after that, we select the PV modules. That's why after that, we select the PV modules. Okay, what is the size and so on. Okay, based on our energy demand. And then after that, sizing and selection of the battery. And then after that, we are going to choose how many battery that we need. What is the appropriate size? Which one is better? Okay, that's the process. First, energy demand. Not buy the solar module first and then put the battery, and then you can use whatever you want. No. It's actually coming. The original one must have outcome. The first target is to fulfill 1 kilowatt hours of system without disturbance. Okay. Then we choose solar modules based on the data. Is it proper or not? If two rainy places or two wet places, maybe we need to change to the place that are just receive the fair rainfalls, for example. Then choose the PV modules. After that, then we must prepare this storage battery in order to support our energy demand. This is the correct one. Then sizing selection of inverter. After that, if you plan to use the AC, then you choose the AC inverter based on the system. Then after that, use charge control. For example, use MPPT. Then other BOS, bench of system. Depends lah. If you want to put the Arduino, that's a different story lah. If you want to do the monitoring kan for project IDP or FYP, then that's the what we call the accessories lah. Okay. But the most important thing, remember, energy demand is the first. Then after that, we choose PV module. Then we know what is the appropriate storage battery for our system. Okay. If we follow these rules, maybe, inshallah, maybe cannot guarantee 100% or cannot guarantee more than that. Maybe you are not going to face any. Maybe you're not going to face any big problem. Okay. Insufficient energy, the battery dies early. So maybe this kind of issue will not come. Maybe we hope. Okay, inshallah. Alright, this is an example, flowchart and load demand, PVA design, condenser balance, blah 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 blah. They will tell me blah blah blah. So just forget that. Okay, so this is the part. So calculation of the load energy and determine the system voltage. So the point here is the load energy and determine the system voltage. They have two types of load assessment: AC load and DC load. This is what I'm saying. You must decide the device that you are going to use. How many bulbs? For example, 12 bulbs of LED, DC lah. And then 1 table fan, DC. And then maybe you want to use you have the Arduino system, for example. So you want to put the Arduino. Of course, they need the buck converter to convert to regulate the voltage to the 5 volt. But it's okay lah. Okay. AC load, for example, you still want to watch the TV even you are in the jungle. Okay. You still want to watch the TV and you still want to play the laptop. Okay, the laptop originally is DC, but we have the adapter. That adapter is suited for the AC only. So you need the TV for your entertainment and the laptop for your work, because you are doing work from home, man. That's why you have work from jungle, right? That you need this kind of okay, it's okay, no problem. How many hours you want to use, we decide it. Then maybe after that we are going to know how much is the capacity that we need, then how much module that we need to buy, and what is the total of storage battery that we need to buy. Let's prepare money lah. But the most important thing is first kita letakkan niat dulu, put the niat at the first place. Nawaitu innamal a'malu binniyat kan, semuanya bermula dengan niat kan. Kena ada dululah nak guna apa. Then after decide, okay, I think this one is enough lah, because we are going to, for the standalone system tu, don't expect too much lah, that you have the 24 hours air conditioner. That's very, what we call that as the naive thinking, okay? Alright. Then, after that, daily requirement for electricity, unit of consumption for C is, everyone knows, is energy unit, is watt and hours. So, in watt hours. So, watt hours is the unit of the energy, okay? Where the E required daily is daily energy requirement, watt hour per day. Remember, you want to use this device, but you need to fix how many hours that you can use for the TV. Macam budak-budak kan, budak-budak mak kan, boleh tengok TV sejam aja sehari. Lepas tu kena tengok handphone sejam saja sehari. Contoh, that kind of limitation. We have to put that limit. If not, it's unstoppable and unlimited. Bukan manusia selalu menginginkan yang lebih kan. Nafsu sentiasa bertambah-tambah kan. You need to limit the nafsu there lah. Okay, you need to restrict it. If not, not enough lah. Even though you have the 1,000 watt hours of battery also is not enough, because human always not enough, right? Everything's not enough. Okay. Then remember, per day. Okay, this example, design example. For example lah, I need 4 bulbs of LED. This is DC LED. Okay, so I need the LED light. I have 4 quantity and the power per item is twice. I want the brightest one. I use the 25 watt, which actually you can get 12 watt also. I think okay lah. 12, LED downlight, standard LED downlight in your home. If you use LED downlight, maybe 15 to 18 watt that size Okay, this size, the pump size I think around 15 to 18 watts per unit. Okay, per unit. But here let's assume 25 watt So then in total, you are going to have 4, then the total power is 100, and you choose to use 3 hours per day. For example, you are going to use from 7 to 10, and after that you are going to sleep. So we need to use 3 hours only per day for each bulb. Then multiply with 100 total power, the watt DC, then we are going to get the 300 watt hour DC lah, for the case of DC. 300 watt hours. Only the bulb, you need 300 watt hours already. And then, like I told you, we still need to do work because we are now working from home. Then you need to have the desktop or laptop. And then we need to have the TV because we want to get updated with the bulletin utama to see the news. Then quantity is 1, and then the power per item, because the smart TV now, I think less than 100, 75, bigger size, but the less because they use LED and LED based what you call that, the display. Okay, LED display or OLED or LED and then we have the desktop there. Desktop there will consume directly mostly from the power supply. Okay, maybe 100 watt. I just assumption. Or maybe laptop. Okay, laptop maybe 75 or 80. 70 or 85 less than 100 watts of the adapter. You can see from the adapter. So the total is still 200. But the TV, because you need to watch the maybe there's some shows kan, macam 7 hari apa bedah cerita drama tu kan, kau nak tengok juga 2 hours tu kan, letak juga 2 hours kan. And then desktop buat kerja sejam je, berehat 2 jam tak kisahlah, whatever lah. And then the total going to be 300 watt hours also for the case of AC. Okay, let's say we have this kind of load okay, in our reban contohnya, in our rumah, tak tahulah rumah apa kan, rumah yang kita isolate, tak nak orang lain kacau kan, kita nak berzikir kan, seorang-seorang kat situ. Okay, so that one we know how many watt hours of what do you call that, appliances that we need to use or we really want to use on our isolated house kan, isolasi punya rumah isolasi kan. Then calculation of the energy and determinant system voltage, there's several cases also, not same for this module, not same with the SEDA one. So we are focusing on the losses is coming from the general system efficiency. Okay, general system efficiency is total the efficiency of cables, the battery, and the charge controller. Okay, this is the total up. It looks like the rough value. Okay, maybe say that 80%. Okay, 80% meaning 20% of the energy is lost. Maybe because the cable and so on or maybe 70% is depend on the question lah. Maybe go 70 to 80% of the general system efficiency mean 20% or 30% is lost because of the cable and so on Okay, next, what is the general system mean? Overall, lump sum, the lump sum efficiency, that means the lump sum deduction losses. Okay, general system efficiency including battery and so on. Next one is the inverter that we use. So that is why this is the critical part. This is always happen to the people who install the PV system, which specifically are newbies. They want to use AC. To be honest, they want to use aircon senang cerita lah. But the inverter that they use, of course, people are choosing the cheapest one. Cheapest but the bigger size. This the human desire kan. Biasalah kan, semua orang pun nak macam tu kan. Kita nak yang saiz besar tapi yang jimat. Okay, that's why we don't really care with the inverter efficiency. Even though there's written in the description, we don't cross-check because we are looking for the cheapest one. Okay, so please don't buy the inverter. Even they write the pure sine wave inverter still. If there is no appropriate data sheet, better to avoid. Better to avoid. Even me also, I will choose the cheapest one. But please, at least if you want to buy it from the online shop, please find the cross-check between the description and the original datasheet, and also ask the shopper because it's about money. It's about your cost. Okay, the inverter efficiency is quite critical. Seriously, if you choose, if you wrongly choose that, you are going to be struggle when your system is always shut down, because actually it's coming from the inverter, because the AC load is quite heavy, plus the efficiency of the inverter is out. Maybe originally only 5 amps, it can goes double. It can double up or triple up your current consumed only because of the inverter is not appropriate. That is one of the reason why always they usually use air conditioner, to be honest. So use aircon, no, not enough. Battery is not enough. Battery, then increase the battery always. But they don't change the inverter itself. So this one of the mistake maybe, personally. Okay. A good inverter, one designed for use in standalone build system, for example, will be about 85%. I told you, at least 85%. You have the exact number declared in the datasheet, cross-check with the description, and asking the company. If you want to do seriously, that's why you need to go for a proper quotation and a proper datasheet. Even though you ask some person which declare them as the consultant of previous standard system, but please don't trust them unless they have the SEDA certified standalone system. If they don't have, they said, I'm always working with that. Okay, I already designed 100 houses installed under my hands. Even say they declare like that, please don't trust them 100%. You need to check by yourself. This is the reason why we are learning this. Okay, don't 100% rely on them. You need to cross check the inverter, what type of inverter that we're going to use, what is the price. Please cross check the data sheet. They can provide the data sheet or not. Please cross check again, and then before you or if you decide to buy by your own, then please check it properly. Okay, please check it properly. Okay, because these are going to be your burden if you wrongly choose this one. Seriously, your device AC will always, I mean, the battery is not enough. There will be issue, battery is not enough, battery is not enough, battery is not enough. It's actually not 100% on the battery. It's actually maybe comes from your inverter. Actually, I've tested before. I put in the TV, the old TV one. You can calculate, and you can see at the back. There's a specification of the TV, kan, the rated value, rated voltage, and the rated maximum current and rated power. You just create the what rated power. You can calculate roughly P equal VI. Then you can maximum load current that comes from that TV. You can estimate. You divide into 230 and so on and so on. But when I have the multimeter, something like that, in the inverter. So inverter, that one I just use the solar car inverter, less than 100 ringgit, very cheap and very simple and easy to install, something like that lah. That kind of features. Then you use that. When I use that, I put the multimeter there. The current is actually double or triple from the original one. And then the battery dies very quickly. Because of that inverter. It's not because of the battery itself. Battery, you can go battery test, kan. Pergi kedai battery atau jual tayar ke apa benda, you can, kalau ada orang ada battery test, ataupun kalau you ada battery test sendiri, you boleh check lah berapa kapasiti yang tinggal. That one battery test is the capacity, it's the ampere hour, for example. But you can assume if under AH, half only. If you have the 40 AH of the battery, assume at least you have 20 something. AH is the normal condition for the capacity. Okay? Or sometimes more than that, something like that. At least if it become half also, okay lah, no problem. It's not about the battery, it's about the inverter. Okay? It's about the inverter. Especially if we buy the cheapest one. Boleh ke? Faham? Asif? Boleh? Asif?
Ya, doktor.
Boleh?
Boleh, boleh.
Irfan, okay Irfan.
Okey doktor.
Boleh lagi Oh, ngantuk punya. Syuhada, okey Syuhada. Boleh Syuhada?
Boleh, sir.
Masih boleh lagi Alhamdulillah. Okay, allow me to proceed. Okay. Alright. So calculation of the load energy and determine the system voltage is not that difficult. It's very super simple. For example, very super easy. Okay. The E required daily device energy required is actually the total energy demand that includes the DC and the AC of your system. Okay. The equation is very super simple. So DC load energy, this is the DC load energy. For example, just now we have the 300 watt hours. And this is the AC. Same, we have the 300 watt hours also, but we need to divide with the inverter efficiency. Okay, inverter efficiency is coming up here. If 85%, then 0.85 lah. If 90%, then 0.9. Then the overall general system efficiency is coming here. This is what I say, maybe 80, maybe 75, or maybe 85. Maybe you put 80 is also okay. Okay, for the battery general system, for the general system efficiency, including all the losses that come from the cables, connection, battery, and so on. Okay, rough numbers. Okay. So we have this kind of standard inverter battery bank, and then DC load, we have the 300 watt hours. So the logic of the equation, this is the logic of the equation. Why we call it that? It's coming from 300 watt hours here, and then we have the AC load also that costs us 300 watt hours. And then we have the 90%. Okay, we have the 90% of the inverter, for example. So before the inverter, okay, means that even though we only need the 600 watt hours in total of the energy for our loads, it's actually after we considering the inverter also, because of the losses there, because of efficiency, it's actually not 300. It's 300 over 0.9. Because 90%. So 90%, 10% is losses. So we need to over 0.9 lah, in order to get the what is the total pula until the inverter, how much is it, the energy. Not 300 watt hours anymore, not here. Now we are considering here over 0.9 before the inverter. Alright, and then this one is the same. Okay, the same. So it comes to the charge controller. Then, like I told you, we assume all the cable, general system efficiency that coming from the charge controller connection, and so on, battery bank, maybe platers, connectors, everything. So let's see 85%. Okay, 85%. Means that, okay, total will be divided also with the 85%. Okay, originally 300 watt hour plus 300 watt hour over 0.9, then we must divide with the general system efficiency, which can cost us, if I'm not mistaken, the calculation becomes 745 watt hour per day of energy that we need every day for our system. Okay, now we know the rated of our PV modules. Our PV modules must at least able to supply 745 watt hour per day of energy. Okay. Originally, like I told you, originally we need only 300 plus 300. But after all the inverter, considering inverter efficiency and general system efficiency, is actually not, if you have the 600 watt hours of system modules, is not enough. Okay. If we only supply 300 watt hours, then going to be the problem, same problem with the brothers, that newbies, with the newbies brothers, they said, oh, battery is not enough, my system shutting down. Maybe battery, we need to increase another more battery capacities. Actually, it's not the problem. It's us. It's about us. We don't calculate, we don't consider this kind of efficiency, this kind of losses. We only assume 300 watt hours, but actually it's not only 300 watt hours. It's more than that if consider all the system. So 745 watt hours. I think maybe this is around additional 145 watt hours kan? Additional 145 watt hour, maybe extra 25%. So we need to have the system that can supply 125%. Mean the capacity for our PV modules must be able to support 125% of our load. Not 100%, 125% of our load, because we have the losses that comes from the inverter efficiency and comes from the overall system efficiency. Boleh ke Syahira? Boleh ke?
Boleh Dr.
Okay. Ridwan Arif. Ridwan, tak ada. Li Yao Meng.
Okay, sir.
Okay. Boleh.
Okay, sir. Okay, sir.
Christopher.
Okay, sir.
Okay. Atir ke Athir?
Ya, betul.
Boleh
Boleh.
Okay. Alright. Let's proceed. Okay, let's proceed. Okay. Then we know how many watt hours that we need for our system after consider all the losses. After that, then we need to choose the system voltage. System voltage, or abbreviated as SV, bukan supervisor, is SV system voltage. Okay, it's the nominal voltage at which the batteries, charge regulator, and solar array operate. I believe you are all and very common with these values. Okay, system classes often operate at system voltage PVSA. Ada PVSA, power photovoltaic standalone. Okay, ada lagi. Lupa nak sebut pula. SAPV or OGPV. SAPV ni benda pula stand alone PV. OG is the off grid. Okay, off grid. So SAPV or OGPV. Okay, PVSA ni pelik aku macam PSA bunyi. Okay, SAPV system voltage tak nak lah. PVSA ni tak syok. Saya cancel jap. Tak syok. Kalau paper SAPV. So SAPV system voltage is 12 volt, 34 volt and 48 volt typical. Dia ada juga also 96. Okay. So 12 volt and 24 volt is based on the 12 volt battery lah. Based on the 12 volt battery. Okay. The lead acid band. The lead acid one. Okay. 12 volt, 24 volt, what does it mean? It doesn't mean that we have the one pieces of 24 volt. Yeah, we have also. But it's simply you can combine two battery with the rated of 12 volt, combine in series, then you get a total up of 24. The same with the 48. You have 4 pieces of battery with 20 volt rated voltage. Okay. It's the same with the normal lead acid battery lah. Okay. And then, so it is recommended to use SV. Okay, this kind of SV, I mean the system voltage not supervisor, is based also from the SEDA. This one also from SEDA. Okay, and then, so recommended one. E required daily if less than 1 kilowatt hours is 20 volt, 12 volt is enough. Okay. If you plan to use 24 volt, okay, no problem at all. It's better and very good. But the problem is the cost is not efficient and the system too not to. But you can increase the load. But the recommended one, if less than 1 kilowatt hours, enough with the 12 volt. When your load energy demand that you calculate just now we calculate 745 kan? 745 watt hours, almost 1 horsepower kan, per day. Means that the recommended one is 12 volt lah. 12 volt is enough. If you want to use 20 volt, okay, no problem. But the cost is yours. Okay. But if you load between 1 kilowatt hour to 4 kilowatt hour, yang ni sekejap ni macam ni kot. Tak kisah, whatever lah. Between 1 to 4 kilowatt hours, then you need to use 24 volt DC. Okay, if more than even 0.1.01 kilowatt hours, recommended one is the 24 volt. Okay, if more than 4 kilowatt hours is 48 volt. And the rest, you are going to parallel your battery to get more capacity. Okay, to get more storage capacity is to make it parallel. Okay, make it parallel. But it's the different issues lah. When you connect to parallel to, make sure you have the isolator between the battery lah, to avoid. Basically they don't put. You are going to see, safety and spark and something like that. If you disconnect directly parallel to, dia akan ada spark sikit. Okay. Better use some insulator or you put isolator or fuse between the battery also can. Okay. If the connection of your parallel is a lot. Okay. So remember, this is also one reason why the system that newbies install not enough. But they say they are expert. They declare they are expert. And the customer, because doesn't know anything, customer doesn't know anything. Customer is very sincere and honest. So just follow, pay the money and follow the expert says. We just follow the expert install that. So we just say, okay, thank you, like that. If we know this kind of thing, we are not going to be cheated, inshallah. Okay, at least we know this kind of thing. Then when they say if more than that, they say, okay je, my kilowatt hours, for example, 1.2 kilowatt hours. They said, okay, 12 volt is enough. No need. Okay. You say no. I'm following the standard. We have the 24. You know what happened? If we wrongly choose, if your load is actually 2 kilowatt hours, but and then you use the 12 volt DC, the total, if all the appliances, all the load are running in the same, running simultaneously at the same time, okay, the drop of the voltage will be more. That's the main problem. Okay, that's the reason why. The drop of the voltage will be depend on the amperes that you use. But I don't know lah. You need to do further study to see the rate. What is the rate? Maybe you can do by yourself. Maybe for FFT project also can. The drop percentage to the capacity, for example. Okay, the drop percentage is very critical. So if you use lot of load, the battery will drop more sudden and more steep than the single load. That's normal. Okay, if you use more, then it will drop more. So that drop more, when the voltage, for example, drop 2 times than normal, then the charge controller will start to turn off. For example, charge controller set at 10.8 volt, a lowest spot. Okay, lowest spot. Originally, if you have the 12 volt battery, if you live like that for several days, they will maintain at between 12 something, 12.3, 12.4, around that, or 12.2 at that 12 volt nominal voltage. Then after you use that, it will drop. So if you use longer and will slightly gradually drop, and if too much energy spike current, then it will drop more on all sudden. It will happen to when the voltage is reaching quickly reach at the bottom value of 10.8. Aku cakap ni faham kau ni. Contoh this is 12 volt something and this is 10.8 volt. If we use at the first place, we turn on our system, maybe voltage like that voltage like that. Let's see, I put here just example. This 0 time and this the 1 and this 2. I mean T1 and T2. Okay. Maybe at 0 time, nothing happened. Then start from the middle, then you start turn on your load and it will drop like this. And then by time it will drop like that lah. The battery, the pattern of the battery. Okay. If you measure the voltage also, you can measure if you don't trust me. But if you use more load at the first place, when we multiply the loads, it will more go down because the amperes is more and it will drop more. So imagine if you use the 2 kilowatt hours of load, but you use 10 volt battery, it will easily reach the bottom level and out. And then charge controller will automatically turn off because we have the over discharging and turn off. That's why battery off, not battery dies, battery off lah. Then your device is stop hot and then you say, not enough battery. It's not actually not enough battery. It's you who choose the different size, who choose the wrong size of the battery system voltage. That's the reason. One is the load. Load we don't calculate. buy modules, buy battery, use everything you want to use. Oh, not enough batteries. Actually not. We are not planning it. We are not planning it properly. Before we do the buying, we purchase the things that we are going to do. Before we do the installation. That's why I'm keep studying again. I'm still studying. That's why until now I haven't bought nothing. And I don't want to risk myself. I don't want to waste my money for that. If from my mistakes. Okay, that's why you are learning more and more, and that's why you are delaying year to year lah. Haven't installed yet. Haven't bought even one battery yet. Even one module. One module I bought already. Okay. Ui, betul cakap seorang ah. Semua senyap. Divania okay?
Okey, doktor.
Okay boleh
Boleh.
Attention tak critical lagi. Dia lebih pada more to knowledge lah. Seriously, I think this don't miss this class. The please focus. I'm afraid maybe one day, I believe maybe one day you are going to refer it back to this chapter maybe. At least you have this kind of thinking when you do the installation, that's all in your head. So you are not going to do that kind of silly mistakes. I mean this kind of mistakes, if you don't learn here, will make mistake because people are a lot of money, they have a lot of money, they have a lot of interest. They have maybe budgets, they want to buy, they want to impress person. I'm using solar. We just use solar, something like that, because trending, everything is trending. So people are following trending without knowing. For us, we first ilmu. Okay, first ilmu, then after that we go to the practice. Beramal. Okay, after ilmu then amal. Boleh? Asal dia terpotong? Nama terpotong dekat sini je Slide terpotong. Wow. Potong lah dia. Sebentar. Tak habis lagi Tengah habis pula. 3.5 kita habis lah. Okay. Potong pula ni. Sorry. Okay. Back. Alright. Okay. Okay. Chronologically from the batteries, 12 volt batteries. Okay. Most small standalone PV system, especially solar home, use 12 volt DC as their system voltage. This means batteries are configured at 12 volt DC and the charge regulator and modules are rated at 12 volt DC. I mean, this is for the use that very small, less than 1 kilowatt hour only lah. That's why we use 12 volt. Okay. Sometimes 24 and 48 volt DC is used. In such cases, battery and solar modules are wired in series or series parallel lah, so that they are 24 or 48. Like I told you. Okay. 24 means 12 volt is connect in series lah. Okay. 48, then we connect it 4 in series. Then we get 48 volt system voltage. The capacity depends on that battery. If you want to increase the capacity, then you need to make it parallel. You need to make it parallel if you want to increase the capacity. But the risk is there. I told you, the risk is there. Because during the connection, if you make mistake, then it can, can lead to the safety issues lah. And then for the case of 24 and 48, I believe the inverter or the charge regulators, charge regulator or charge controllers appropriate must be selected. Like I told you, most inverter that I've seen until today, for 24 and 12 volt, usually they can both equipped with this. Okay, 22, 12 and 24 volt to in one simple inverter, they have that kind of thing. But for 48 volt, usually separate, and the price is going to be more than the 12 and 24 volt. So this normal lah. Usually very rare lah. They have module with the only 24 volt. Usually they come with the two sets, 24, 12 and 24. They can support both. But please make sure before you buy it, you need to check the rated one. I'm afraid there's inverter also that only support 24 volt. Okay, charge controller and inverter that only support 24 volt. Means that if you have 12 volt, it doesn't support. It doesn't work. Okay, please check it properly. Okay, many charge regulators and inverters can operate at either 12 or same thing. Okay, charge regulator and inverters also, they sense the system voltage and adjust to it automatically. Like I told you, for this case, they already have the sensor there. You don't have to be worried. They will trace 12 volt and 24 volt system. Okay, one of the general limitation is that the maximum continuous current being drawn from battery should be no greater than 120A is the maximum continuous current from the battery, regardless of the size capacity. But I think there's a wording also, they say as a CA. Okay, CA is depends, mean the maximum current, generating current wanted. Okay, maximum generating current is wanted if lead acid battery wanted of the normal capacity. Okay, if the capacity is 100 Ah, so the maximum injected current or the maximum charging current is actually 1/3 of that, which is 33.3. Okay, if the 3Ah battery, so the maximum injecting current or the maximum charging current is limited only 1 Ah. Remember this. Okay, it's actually, if you do the fast charger, we have recently the fast charger system. We have the fast charger for our handphone also. For those who have the 3000 milliAh, I think the normal, if you measure, you download the ammeter apps, you can see the injected current, how much is it. Even though they write 2.4 amps, they are not going until to that 2.4 amps. Sometimes they go 1.5, sometimes they go only 1.8 maximum, or 1.5 or 1.2 for the 2 amps, 2.1 and 2.4. But for the fast charging, maybe 3.0, maybe they have the amps, maybe that one they go to something lah. Okay, there's a charging current is the charging rated also. It's actually pretty rules, even though there is the lithium battery. It's okay lah. Okay, lithium battery okay lah, because phone battery is the lithium battery. But the charge controller, for the lead acid battery, if you want to try, you can Google finding for the battery charger. Usually you can see 5 amp, 10 amps. Usually lah. Typical battery charger. In the Shopee, in the Lazada, for the lead acid. This is for the lead acid. Usually 5 amps and 10 amps. This is the reason. And please read, they have the minimum capacity of the battery that can be charged. Dia ada syarat dia. Okay, kalau untuk lead acid battery, remember, wanted for the sake of the lifetime of the battery. Okay, it doesn't mean that fast charging good. No, fast charging sometimes because they inject the current very fast. Not all of them are totally properly stored. Okay, even they have fast charging. Okay, depends on the battery. Please follow. Please follow. You can see if you buy the lead acid battery also, deep cycle, the black one or the green one, GP brand for example, if you Google, then you will see they will write there almost 1/3 of the rated capacity. Okay, I think for example, if 7Ah, I think 2 point something lah, they say. Maximum 1/3 less than 1/3 capacity of the battery. So this is the maximum charging current. This one is maximum continuous current withdrawn from the battery. Should be no greater than 110. Quite kuat big lah, kuat high. Ni boleh bersepai kalau kena ni. Lentung. But I think lead acid battery, the CA, for example, if the battery is 40, it can goes up 120 amps discharging. Okay, maximum. But that one 3CA, if I'm not mistaken, for the lithium ion, not lead acid. Charging current, remember, for the lead acid is 1/3 from their capacity. Okay, if 10 amps mean maximum maybe 3.3, they are written in the outside of the battery casing. Betul. Okay, boleh lagi Fatin Adawiyah.
Boleh doktor.
Alhamdulillah. Sikit lagi. 3.5 kita habis. 3.5 kita habis. Alright. Daily system charge requirement. Okay. Divide the revised daily total system energy requirement by the system voltage. Okay, we know already system voltage. Next is to calculate daily system charge requirement in M hours. Ni selalu tengok kot. Kan? Selalu nampak kan AH ni. Ataupun tu handset korang tu. Dia tulis dalam milli AH. Yang beribu-ribu tu kan. Kalau Redmi ke, apa benda ke, mungkin ada yang 4,000. Ada yang up sikit. Sampai 6,000. Macam saya punya kan, Redmi 90 kan. So dia sampai 6,000 milli AH is actually equal to 9 AH je. Saya pun tak tahu kenapa dia tulis 6,000 milli AH. Why not write 6 AH finish? Maybe they want to impress, when the numbers is bigger, looks like wow, kan? That's why they write until now. For the battery, phone battery, they are not going to say 6 AH, but they write 6,000 milli AH. Same goes to the battery banks, okay? To battery bank, power bank. Power bank also the same. 20,000 milli AH is actually equal to 20 AH lah. Why not write 20 AH finish? Small number. But we like the bigger numbers. That's why they write 20,000 milli AH. Kalau you perasan lah. Tak ada reason pun. Tak dosa pun. Saja nak tanya lah. Itu je lah. This is the charge in M hours. Okay, remember. This is the charge in M hours that the modules will have to provide each day to meet the load requirements. Ini critical. This is the critical one. We have to calculate daily system charge requirement. Means we have to calculate our AH per day. How many AH that we need today? This is the key. Because this AH will relate to the battery capacity which in the AH unit also. So this is what we call daily system requirement will be divided with the system voltage that we choose. If 24 lah, getting smaller lah. If 10 volts, getting higher lah, the value of ampere hours. Okay? Remember, first of all, we decide device what we want to use. We calculate what hours. After that, we includes the efficiency of the inverter and the efficiency of the general system, deduct and so on. Then we are going to get the how many watt hours that our system, our modules need to supply. Then after that, based on that watt hours, we choose the system voltage appropriately. If less than 1 kilowatt hour, 12 volt battery is enough for our system. If you want to use more, 24 is okay. Mendapat pahala lagi, tak ada masalah, tidak berdosa. Okay? No, it's not sinful. Okay? You can use bigger. Bigger is okay, no problem. It's always like the tolerance. If positive tolerance, no problem with that. We don't have issue. But the smallest one is quite the issue because it will stop your system and you start to murmuring. Oh, got that. You start to membebel kan. Wah, pasal ni rosak semua, tak cukup bateri kan. Okay. So once you get there, divide with the system voltage, then we are going to get the ampere hours for the system. That ampere hours will be based on our original energy demand tadi tu. AC and the DC loads. When we get the ampere hours, now it's clear. Okay, every day I need the if 745 multiply with 12 berapa ni? Dia contoh belakang ni. Tak ada. 745 divide into 12. Boleh kira tak? Boleh tak sama-sama kira? 745 divide with 12. How much you get? Izzuddin, dah siapa? Bagi kira. Mirul.
62.08 sir.
Okay. Ini contoh 62 point saya nak for decimal tak apa dah. Boleh. Okay, means that for that 4 bulbs of LED, 1 TV and 1 desktop or laptop, we need to have 62.08 AH of the capacity of ampere hours every day. Means that if you buy 1 ada AH battery, is it enough? That's a different story. Belum lagi. Tak masuk lagi So maksudnya, it means that so you need to have 63 ampere hour of the system in order to fulfill our energy demand that we have set at the first place. Okay, 62 have, okay, no problem. But is it okay we just use the one simple battery of 1 AH? Is it true? After that we know. Okay, sikit lagi, 8 minutes. Okay, finish we tahu AH. Okay, next check which month as the lowest mean daily insolation. This is called the design months and it used to size the array for standalone system. Most of grid PV system are designed for the months of the year with the lowest insolation so that when the sun is least available, the system will work. This is about the table of solar irradiation basically from the previous data lah. Okay, from previous data. This data you only can get if you want the real values, you need to buy from the, again, like promoting Meteorological Malaysia. I think this one is correct. Sekejap saya check. Yes. Okay. Saya tunjuk dah lalang buka ni. Sekejap. Okay. This is the website, official website of Malaysian Meteorological Department. So Ministry of Environment and Waste and Water silap. So there's observation, earthquake, forecast, main forecast, marine forecast, weather, aviation, nowcasting and so on. And then you can buy the data, you can ask for the data. The data is not available here, they can get from here lah. Boleh email direct kepada person in charge. Okay, if you want to have the specific data from here, then we can get even the Hidden data, so we can get. Okay, we can get. They can provide to us, but that one for the closest station. For example, for our case, then if for our case, Kuantan or Muazzam is the closest one. Okay. So this is the MET Malaysia, MET, met.gov.my. Okay, don't forget to visit this website. Okay.
Doktor.
Yes.
Data dia akan diberikan secara percuma atau
betul. Semua tak free. Kalau yang daripada MET ni memang kena bayar. Tapi dia adalah package dia tu. Kalau tanya tu email tu mungkin lambat sikit dia reply. Tapi dia boleh provide lah. Macam data tahunan macam mana, kalau nak data per hour pun ada juga. Kau nak data tahunan saja ke kau nak data per hour pun ada juga. Dia ada harga-harga dia lah. Saya tak boleh beritahu harga lah. Nanti saya tahu cik makan. Nak beli kat saya boleh. Saya makak sikit. Contoh gitulah. Boleh dapat lah. Data tu boleh dapat insyaAllah. Ataupun boleh generate interpolate from Meteornom ataupun PVSys. Ni software dia boleh provide lah yang data irradiation tu. Saya tak tahu saya tempat dia nak tunjuk benda tu. Okay. So ini basically macam ni lah. Dia akan design months tu will be based on the lowest months. For example, this one is during the July, the lowest is for 4.5 kan. 4.5 year, the lowest. So all the peak sun hours that will be taken is based on the 4.5 hours only. But I think this place is quite higher. I don't know which place it is. There's some place also in Kuantan, they declare recently. I just read some document and they're very interesting. The NEM document, some brothers share to me. So he just asked for the quotation for NEM, Net Energy Metering. And I think he's living in Kuantan. And the size, the peak sun hours declared by the quotationer pula, apa nama tu? Provider consultant ke ataupun seller ke, 3.5 hours only 3.5 hours. Ini untuk Kuantan lah. Saya rasa dia dari Kuantan. Tak ingat mana, Indrapura ke mana. The peak hours declared there is 3.5 hours. I think there's data for that particular area kot. I think they're looking from the last year kan. You know, last year kan quite heavy rain kan. With the flood, everything. That's why maybe they considering the December, I think. December for the Pantai Timur side ni, I think they will consider mostly on the December and January because heavy rain kan. We have the monsoon there. We have the flood season there. With the high rain, heavy rain season there, maybe they'll consider based on that December lah. December is the decision for this peak sun hours. Okay. So you need to check. This one also data provided. You can check from the for example, if or interpolate the data from there. So they have the data. That data is very critical lah before you proceed with the installation. If you see, for example, I think 3.4 okay, but if you see 3.0 and 2.7, if you see this kind of, maybe this is the answer of not better for you not to install lah because I think it's not worth. Maybe. Okay, sikit lagi, 30 minutes only. Sizing and selection of battery and PV module, then finish. Solar resources, we have that, and then PV module sizing and the battery sizing. Okay, let's say we have the 100 watts of the modules. I think this one is poly. Okay, why poly? Because everything's rectangular, no diamond, and it looks bluish. Okay, bluish. Maybe this is the poly crystalline. Okay, have the VMP there 16, and we have the IMP there, we have the VOC and IC. Okay, so we call that as the minimum watt peak. Okay, minimum watt peak, total energy demand. Then after we get the 7 for just now 4.5 it's okay lah, just start with the new, okay, with the 4 hours. So we consider equivalent sun hour peak VSH with the 4 hours per day. Then our energy demand is 745. Then we divide it, 745 divide with 4, then we get 186.25 watts. So if we use the 100 watt modules, so number of panels that we need in order to make sure that we can supply enough power to the modules, to our battery, to our necessity. So we divide into the original PMP, then we get 1.86, and of course, because this is a minimum watt peak that we need for our PV modules, then we are going to need 2 panels lah. We round it up, okay? Because it's minimum, then round it up become 2 panels. So we need 2 panels of 100 watt. If we use the 200 watt panel, so we only need one lah. Okay, we only need one. Okay, 100 watt of modules. Okay, ni last part lah ni. Okay, kan? Okay, dapat. Okay, this is an example. Okay, PV array sizing. Okay, since area kite daily for our system is 745, right? Kita dah kira tadi 745 watt hour. The recommended SV is 12 volt. Okay, recommended SV is 12 volt lah because less than 1 kilowatt hour. Okay, less than 1 kilowatt hour. Therefore, since the module's VMPP is 16 volt. Okay, 16 volt coming from where? Coming from here. The MPP or VMP here is 16 volt. Okay, 16 volt. Therefore, since the module VMPP is 16 volt, which is greater than the SV, only one module is connected in series. The rest of the modules will be parallel. I repeat. Our VMP is 16 volt, but the system voltage is 12 volt. So it's enough for us to charge the battery. Kasar pula kan. PV modules voltage must be higher than the system voltage in order to charge the batteries. So the voltage can be regulated, can be boosted. Can be regulated lah. 16 volt can be regulated to 12 volt, no problem. So means the battery can be charged. Okay, it's enough to be charged. So no need, it's enough for us to connect in series one only. Because just now we need 2 modules. 2 pieces of modules of 100 watt. So we need 200 watt kan? Okay. VMP is 16 volt. So the connection arrangement of modules in 1 series and 2 parallel. Because we need only 1 modules connected in series in order to charge the battery because the system is 12 volt. So the connection is become like this lah. Macam mana tu? Macam mana aku nak sambung lah? Macam ni kot. And then ni charge controller lah CC. Okay. Let's say lah ini minus, ini positif. Okay. So ni kita ada bateri pula sini. Sorry, semua singet. Battery. Okay. Means that our modules will be connected in parallel. So like I told you, we have the connector. Yang ni boleh beli connector dia lah. Dia ada nama dia MC4 connector. Saya ajar satu ni. Ni boleh beli dekat online ada. MC4 connector. Okay. MC4 connector. Connect it because we are connected in parallel. Please find for the parallel one lah. Okay, parallel. If series, no need the MC4 connector. Parallel we need. Parallel we need the MC4. Series you just plug in and series macam ni. Series sambung macam ni lah. Sambung macam tu je. Sebab ni memang ada male female kan. So sambung tap macam tu je kan. So ini when we parallel. Okay, when it is parallel, what is the advantage of this module configuration? What is the advantage of this configuration? Tanya siapa? Siapa tanya ni? Divenya.
Yes.
If we connect our modules in parallel like this, what is the benefits? What is the benefits? Ada idea tak?
I'm not sure, Doctor.
Not sure Tak apa, saya tanya orang lain. Radi. Saya panggil nak 2 kali nama Radi. Radi. Ada situ tak? Ada, Alhamdulillah. Apa benefit when we connect modules in parallel? Apa benefits dia? Rasa-rasanya lah.
Tak pasti.
Okay, tambah lagi. Kat sini saya tambung terus kepada charge controller lah yang masuk dekat bahagian input PV tu masuk. Lepas tu kita ada bateri kat sini. Okay. Clue dia berkaitan dengan bateri. Tak pasti?
Tak pasti.
Tak pasti. Kita tanya orang yang lain lah. Owi.
Ya, Doktor.
Apa benefits kalau sambung modules in parallel? Kita sambung charge controller dan ada bateri dekat situ. So dia berkaitan dengan bateri.
Dia pasti.
Teka je. Janganlah banyak sangat tak pasti lah korang ni. Teka lah. Tak boleh teka. Teka je. Tak pasti tak? Mirul.
Tak pasti.
Mirul macam
Kalau
nak jawab.
voltage Doktor,
Apa?
kalau voltage,
Ulang balik.
voltage.
Kenapa dengan voltage dia? Apa terjadi kat voltage dia tu?
Sebab kalau in parallel kan voltage dia kan sama lah nanti yang dapat.
Okey. Voltage sama betul masalahnya.
So nanti masuk dekat bateri tu je. Nanti macam kalau dia nak bekalkan 12 volt, nanti sama je lah nanti.
Tak. Macam tu tak perlulah sama parallel sebab ada 12 volt. Kalau sama parallel pun 12 volt juga. Betul tak?
So mungkin current akan increase.
Okey. Bila tak ada voltage, jawapan dia current. When we do it parallel, the current will be parallel. Modules, if you connect in parallel, the charging current will be multiplied, will double. If you parallel 3, current will multiply 3 if in the same modules type. Tahu, boleh? Ganesh
Boleh,
ni
betul.
pernah kerja ni ke? Alamak, Ganesh ada projek Ganesh. Sekejap.
Sir,
Tak ke pernah involve tak? Tak
dulu
ada.
lepas ni ada kerja.
Apa?
Dulu ada biasa kerja.
Oh, batik macam je. Tak cia je ni. Okey. Macam tu. Kita sambung parallel sebenarnya one of the issue sekarang, kita ada bateri. Let's say bateri kita sikit. Our battery size is very small. So, when our battery is, the size of our battery is small, logically when you use load, when you have the load, it will start to become zero lah. I mean, it start to finish earlier, quickly, because the size of this battery is small. So, we always looking for the fast charging, betul? Fast charging, because we want to make it to charge it very quick. So in order to do that, we need to have the charger, the fast charger. How to make it fast? Is to make it parallel. The modules, because the modules, each module will get different sunlight and radiation. We get 5 amps, and then the module also get 5 amps, and if you connect in parallel, then the boost, it will boost up. The charging current will boost up. But if you connect in series, nothing happen, because series kan all the same. Current is all the same. Just the additional, just the sum of the, what we call that? The sum of the voltage is getting bigger kan. 12 volt, 16 volt multiplied with 2, 32. So only the voltage is getting higher, but the current is not getting higher. Different to the GCPV. Okay, GCPV kan, grid connected, like I told you, the recent trending Huawei patent inverter like that. The recent inverter, they are looking for the high voltage but the lowest current, because the target is to deliver the maximum power. It's not the charging current. It's not about that. They want the power only. They don't want the current. They don't want to charge battery. But for the case of standalone, the most important thing is to charge and recharge your battery quickly. If you want to do that, you are going to need the multiple ampere hours or multiple amps high charging current. That's why we make it parallel. And the advantage, if you do parallel, the time to fully charge the battery will become half only. Okay, because we have two parallel. If before that 2 hours, then when you have connect parallels, expected maybe 1 hour. Okay, maybe 1 hour. Alright, I think I stop here lah.
Sir, nak tanya sir, kaedah ni macam sama macam yang kereta charging tu tak sir? Untuk cepatkan dia, jadi current dia akan jadi macam mana sir? Lebih kurang macam tu lah kira.
Maksudnya kereta pula ni. Ni ke? Tesla.
Elektrik lah.
Kereta elektrik. Fast charger konsep. Betul. Fast charger tu. Dia lagi amps tinggi. Dia nak charge battery sama macam battery charger lah. Fast charger tu semua looking for the fast charger. Method to do the fast charger, kita ada solar module ni, kita sambung parallel. Baru dia boost up demi current. Begitu. Tapi yang fast charger konsep tu lain sikit lah kan. Dia punya dapat 300 amps tu macam mana. Tu saya tak steady lagi lah untuk electric vehicle. Electric vehicle issue is we need the fast charger because we can't wait several hours to fully charge our batteries. That's why we need the full charge battery. Fast charging kan. Then maybe we just have to stay maybe 1 hour to fully charge the batteries, then we go for the 400 kilometers again. Sebelum ni mungkin initial electric vehicle punya station is on the home, at home kan. So usually they put it overnight in order to fully charge. Itu yang dulu punya the earlier season of the EV era kan. But now you can get in Petronas, I think now we have one parking for the EV kan, EV charger kan. Lepas ni dengan Macam dah cas kan, berapa ratus ringgit saya tak ingat per kad tu, per bulan per tahun kena bayar. Macam tu lah. Boleh? Okay. Alright. Any question? Any question? Okay. I will release assignment today because we can't wait anymore because drag untuk lab tu macam okay lah, siapa yang tak dapat 3 kilowatt you can reduce it 1 kilowatt only lah. Okay, last discount 1 kilowatt only. It looks like there's some problem, and make sure again I state, make sure you have to produce first of all the IV curve for a single PV cell. You have to make sure that you get the IV curve, exactly what we have learned before in the chapter 3, that curve. If you can't get that curve, means your system, your circuit is still not correct. You have to work on until okay. Then after that, easy for you for the modules because I'm giving you maybe 20, 30 cells and connected, something like that. Then you get produce module kan. Then after that, you need to design for 1 kilowatt, 3 kilowatt or 1 kilowatt. That one become easier. The first one, single PV cell must be correct. Okay, and also when you do the 3 kilowatt or so 1 kilowatt or modules, you have to make sure that modules is correct also the connection between the cells. Okay, so Simon, I can't wait anymore. So I will release actually last week, tapi because you haven't finished the lab yet, mostly maybe some of you already submitted, but some cannot, so some problem, maybe too heavy for the software. Then I will release between tomorrow assignment is about calculation of the GCPB grid connected. Okay, the calculation of the connected, I think very straightforward for me. It's very straightforward from the beginning design criteria, choose the inverter, and then you do the inverter voltage matching, and you have the 4 products. I think it's enough. Then the submission, okay lah, you can drag until study week lah. Okay, study week, right? And next week on Friday to Sunday next week, so we are going to have the quiz 3 and quiz 4 and then some. So quiz 3 and quiz 4. So that one, if something happen again, please PM me lah after that. Okay. But please follow that one. Okay. Next week, Friday to Sunday. If something happen, then contact me. If you can't do during that time lah. Okay. So any question can PM in direct, right? Apa lagi? Itu dah. That's all. We are going to continue for the next week. Okay, next week. I think the last week, the week 14, we are going to have the PSM2 excellent maybe. It just fall on the Wednesday, if I'm not mistaken. So our last class is on that Monday. Week 14, Monday is the last. We're not going to have the class for Wednesday. If you have some question, you can as usual PM me. Okay. Alright. Any other question? Tak ada Okay.
Sir,
Yes.
kenapa saya tak boleh masukkan turn in tu?
Turn in? Kenapa pula? Kejap dah tutup ke? Saya dah tutup tu. Nanti saya buka balik. Saya dah expired kan kot. Apa nanti saya check balik. Saya rasa sebab itu dah set yang deadline pertama tu sebelum extend. Nanti saya check balik Boleh?
Okay, sir.
Okay. Any other question? Are we okay? Are we?
Okay,
Hafiza okay Saya petik nama. Nampak pasifnya kan. Boleh Hafiza? Kan tadi.
Okay, sir.
Oh ada, baik. Yusuf okay, Yusuf.
Okay, sir.
Okay. If no question, then see you next week. Okay? Alright, thank you.